Good evening, all.
Good evening, sir.
Yes, Adesha, after a long time you're joining. Why?
Sir, actually, I was having term 2 exams for 11th class, sir, so that's why.
Okay. Turn to exams from your school side.
Yes, sir.
Okay. How did they go?
It was good, sir.
Okay. Even Pravalika?
So same, so refinance.
Okay. You have pre-final exams.
Yes, sir.
Okay.
Yes.
So I think we have covered all the topics of class 11th. Is there any topics we left with from class 11th?
Almost no, sir.
Yes, we have left with one topic called mathematical reasoning. We will be discussing after a few days. Okay, I mean, like once we will, there is a very small topic. Definitely one question you could see from that. And guys, I'll be sharing many questions from. I'll be sharing many questions of JEE mains. Please go through that. Binomial theorem, permutation, linear inequalities, complex numbers, principal mathematical, trigonometric relations, functions, sets. Guys, we have covered all these topics basically. So next we will go with uh, class 12th topics. Shall we go with that? Have you all started with class 12th syllabus from your school side?
Yes, sir. For us, it started
No, sir.
matrices.
You started with matrices.
So matrices for us it is in 11th only.
Matrices?
In 11th only we are having.
Okay. You are having in class 11th only. So we will
Yes,
do
sir.
one thing. So we will go with matrices and determinants. What do you say, guys?
Yes, sir, it's okay.
Yes, sir.
Okay, we will solve the JE questions on that. First of all, we will
Yes.
discuss matrices and determinants. We'll go with the notes.
So I'll be telling class 12th syllabus from today, sir.
No, it is not like that. I'll be telling the topics of JE only. It is not,
Okay.
JE syllabus is combinedly class 11th and 12th, right? So class
Yes.
11th is nothing but for state board students, matrices and determinants in class 11th. For CBSE students, it is in class 12th. So it is
Okay,
not
sir.
like that. So we'll be teaching JE topics, not like one board. We'll be teaching CBSE syllabus and we'll be teaching state board syllabus. It is not like that. We'll be handling the JE syllabus, whichever class may be, whichever the board it may be. But we'll be taking JE classes. The concept
Okay,
whichever
sir.
we are taking here, that covers for JE mains. Okay.
Okay, sir.
So why is there any problem from your side?
No, sir, actually my father asked about that, so I'm
Okay.
asking.
Acha. Okay, okay, right, right, sure. One second. It is already like you guys have already that topic in your class with the state board students, and for CBSE students they are going to start now, and many of you have guys like done with that topic. I mean, they might have started matrices and determinants from your school side as well. Am I correct?
Yes, sir.
For CBSE students.
Yes, sir.
Okay. One second. Yeah. So we'll go with introduction of matrices today. Okay. Shall we?
Yes, sir.
Yeah. One second. I think there is. Yeah. Yeah. So first of all, let us try to go with matrices. Then, as soon as we finish matrices, we'll go with the determinants. Matrices and determinants. Matrices and determinants. Okay. So in matrices and determinants, first of all, let us try to understand what is matrix. Okay. Can you define what is matrix? Anyone of you?
Sir, an array of elements.
Sorry.
So, an array of elements.
Mhm. Yes. A set of elements arranged in a rectangular array. Okay. Look at, let us write everyone this. A set of mn numbers. Set of mn numbers. It could be any type of number, real or imaginary. Real or imaginary. Okay. Arranged arranged in the form of arranged in the form of a rectangular array. Arranged in the form of a rectangular array. Here m denotes what and n denotes what? M denotes rows, n denotes columns. Okay. And now here I'll be representing matrices like this. M cross n. This is how I represent a matrix. M cross n. This is not into cross. How do we read this as? Cross. Set of mn numbers. Set of mn numbers, real or imaginary, arranged in the form of a rectangular array where m rows, n columns. Clear?
Yes, sir.
Yes. Now look at this basically here. Here, first of all, let me take matrices always I denote with the capital letters. Okay. So if I take this as capital A, I'll write a rectangular box like this. I told a rectangular array, right? Here I'll be writing the elements A11, A12, and so on, A13, A1n like that. So A21, A22, dash, 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 A2n, A31, A32, A34, A33, and so on like that. So look at this dash, 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 you can write AM1, AM2, dash, 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 AMN. Understood my point? Clear? A11, A22. See here, sir, why you are representing with capital A letter and why you are representing with a small letter. So beta here always matrices we represent with the caps letter and elements. Inside we have elements. These elements I represent with what? Small letters. Clear? Any doubts? Inside elements I represent with small letters and representing the matrices what? With the capital letters. Any doubts?
No,
And
sir.
because this is A11, A12, A13, A14, and so on till A1n. Am I correct? All right.
Yes, sir.
So what is the order of this matrix? Order of
M by N.
m by n. How do we read this as m cross n or m by n? You read.
M cross N.
Okay. Basically here, sir, you are writing A11, A12, A13, A14, and dash 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 A1n, right? So here I write that as Aij.
IJ.
Aij. Okay. I write that as Aij. What is I here? What is J here?
I is
I
rows
is row,
and J
beta.
are columns.
I is row and J is what? Column. Column number, row number, you say column number, okay.
Yes.
Row number and column number. Okay, understood? So basically this is now how can I represent? So A is equal, can I represent this as Aij? Can I say Aij?
Yes, sir.
Can we say like that? Yes or no? Very simple. Yes, we can say that. So here Aij gives me what? Number of, okay, I gives me number of, I mean row number, J gives me column number.
Column number.
Okay. Yes. So this is how I represent. Understood my point? So basically, why do we use matrices? What is the applications of matrices? Can anyone of you tell me what are the applications? Where do we use on in our daily life? Where do we use matrices? Where do we use matrices in our daily life? But in many ways we can use. Look at, you might have heard about cryptocurrency, right? Cryptocurrency. Have you heard about a cryptocurrency?
No, sir.
Yes. No problem. Look at, have you heard, look at it, in gamings, in the gaming, framing the gaming applications. Gaming application, we have a apps, right? PUBG game, that game, this game, we have an application, right? Game applications. For framing that game applications, we'll be using matrices. Yes, without even realizing ourselves, we are using many ways. We are using matrices in many ways, in different ways we are using matrices. So like it is not required, it is not important where we are using matrices, but that is, yeah, we have a knowledge. Yes, in behind game application there is a used, we are using matrices. Okay, and look at this beta, in bank number, let's say that you have a Paytm. Okay, you have a Paytm, you are transferring, let's say 100 rupees to your friend. How much? 100 rupees, or Google Pay, Phone Pay, whatever you say. Okay. Huh. See here, when you are transferring this 100 rupees to your friend, it is going to your friend through what? Through what? We are using UPI ID or mobile number. That mobile number link with, mobile number will be linked to bank, and that is how it is getting processed. But whenever you are transferring 100 beta, it is showing you 100, but behind it is showing you 100, right? Behind that there is a big story running. All right, it is not, it is showing 100 to you, but to the system what it shows, it shows the numbers in binary number, like 10, it shows codes, 1011 10 something, 1111 something code will be there. Okay, so it reads that whenever you enter 100, it reads that this code and it process, and so that you will be transferring 100 rupees to your friend. Okay, there will be a binary system. You will be like, if you know the software language, you'll be understanding that it is like, for every number, for every amount, there will be a code. If you send 1 rupee, for that there will be a code in terms of 1101 something like that. You'll be having only 10 numbers only, not 102, no, not other than 0 and 1. All the numbers will be having a coding in terms of 0 and 1 only. Clear? 0 and 1 only. So now look at this. If I have a 2, if I'm sending 2 rupees, RS 2 rupees, RS 1 rupee, there will be coding for that, 1011 something like that. There'll be a code for that. I'm telling an example. If I send you RS like 500 rupees, there'll be a code for that. All right, this code will be running behind that. So this code, how we are framing this code also getting framed by using matrices only. Understood? This is a daily life example. Understood my point? Clear?
Yes, sir.
Why?
Yes, sir.
Sir, why it is having code here? If I send 1 rupee directly, why can't it show 1 rupee? If I entering 2 rupees, why can't it show 2 rupees directly? If I send, if I say 500 rupees, why can't it show 500 rupees directly? Why it is showing that code something like that? Why? Because beta, if I show something like that, if I show 100 rupees, I'm sending 100 rupees, means if I show only code as 100 rupees, everyone will hack your account and they will steal your amount, right? Am I correct? Isn't it? If
Yes, sir.
someone can easily steal your amount. If, for suppose, there is a thieves, there are many thieves will be there, like, those who are like, always trying to steal someone's account and hack someone's account and to steal the amount from their bank account. So they'll be trying that. So if I send some, like, 1 lakh rupees, like this, 1 lakh, 1 lakh, 1 lakh. So for 1 lakh, if you have a code called 1 lakh only, he will definitely steal your account, definitely steal your amount. Why? Because he knows you are sending 1 lakh. So there will be easily understandable code. Okay. For not getting stealed, for not getting steal our amount, for the purpose of our amount is in a safe zone, for making sure that we are using these binary codes. Okay. If you have this much big code, no one can remember that much big code, right? I'm telling you an example. There will be hundreds of numbers like that. There will be hundreds of numbers like that. You can't remember all that. So that is the reason we have a big numbers behind that, in terms of making sure that our money is not getting stealed by some thieves. All right, some hackers. So to save our bank account, we use this matrices and determinants concept behind that. This is a story behind that. Understood my point? So that is a big story which is not required for us. Okay, understood. Hope it is clear why do we use. I hope I just gave some
Yes, sir.
yeah like application oriented concept. Next, we'll talk about submatrix. Submatrix. We learned what is matrix. Now we'll talk about submatrix. Submatrix is nothing but what? Beta, look at it here. Submatrix is nothing but I talk about let's say A matrix, which is order of m by n. What is AMN? How do we read this? There is a matrix called A, which is order is m cross n. It has m number of rows and n number of
And a
columns.
number of columns.
That is the meaning of that. Clear? Yes, fantastic. Now look at this. Let us write the definition of this. Let A m by n be a matrix. Be a matrix. Okay. A matrix obtained by leaving some rows or columns or both. A matrix obtained by leaving some rows or columns or both. That is what a submatrix. Correct? That is what a submatrix. Understood my point, beta?
Yes, sir.
Let me give an example. Look at this here. For suppose example, if I say A matrix, let's say that 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 3 by 3 matrix or not? Yes or no? This is 3 by 3
Yes,
matrix.
sir.
So I'll write some matrix. Let's say that B matrix. I'm giving a B matrix. I'm leaving rows, some rows. I'm leaving one row and writing a matrix. That means this is R1,
5, 6, 8, 9.
R2, this is R3. Okay. This is column 1, column 2, column 3.
7,
All right.
6,
So I'm just leaving R1 now. If I leave R1, what I left with now? 4, 5, 6,
4, 5, 6,
8,
7.
9. So this is how many rows? I have 2 rows and 3 columns. So 2 by 3. Understood my point?
Yes, sir.
Okay. So this is a submatrix. This is a submatrix of A or not? So B is
Yes,
a
sir.
submatrix of A or not? Can I say like that now? Yes. So that is a submatrix. Very simple. Understood? Clear?
Yes, sir.
Yes, sir.
Now let's talk about types of matrices. Let's talk about types of matrices. Types of matrices. Now look at this beta here. First of all, let's talk about row. What is row and what is column? Okay. What is row and what is column? A matrix. Look at this. First of all, let us talk about row matrix, which is row is nothing but row matrix. Matrix is nothing but singular. Matrices is nothing but plural. That's it. Okay. A matrix having only one row. Matrix having only one row is what? Row matrix. Let's say that example. Let's say that. Look at this. If I have only one row, let's say that A, B, C. What is that? M by
Row matrix.
1 by N. 1 by 3. Isn't it? Isn't it?
Yes, sir.
One row. Row matrix is nothing but it must have only one row, beta. This is row 1 or not? Only one row. How many columns you have here? 3 columns.
3 columns.
This is column. Okay. Clear?
Yes, sir.
Yes. Next. Second. column matrix.
Column matrix.
Column matrix. Column matrix. I'm writing a short way. Okay, column matrix, which is nothing but a matrix.
Having only one column.
Having one column.
Simple. Matrix having
One column.
only one column. One column. For suppose example, let's take look at this. A, B, C. How many columns you have here? 3 rows.
3 rows,
Three
1
rows, one
column.
column.
3 by 1.
Okay, 3 by 1. So this is row. This is column. Okay, very simple. Now square matrix. Next type of matrix is square matrix. Okay, what is square matrix? A matrix in which m is equal to n, which is nothing but there are number of rows is equal to number of columns.
So like 2 by 2, 3 by 3.
Yes. A matrix in which m is equal to n, a matrix of order n. You say a matrix of order n. Here you say a matrix of order. Okay. Yes. Let's say that example. Let's say what is square matrix? For suppose you have 1, 2, 3, 4. Okay. What is the order of this matrix now?
2 by 2.
Okay. What is the order of this matrix? 2 rows, 2 columns. So here m is equal to 2, n is also equal to 2.
N is equal to.
So you can say that is m is equal to n or not here. So that type of matrix is a square matrix. Understood my point?
Yes,
no?
sir.
Next, fourth one is diagonal elements. Diagonal elements. Diagonal elements. What do you mean by diagonal elements basically? Look at it. Diagonal elements is nothing but elements A, I, J, where I must be equal to J in any matrix. In any matrix. Elements A, I, J, where I must be equal to J in any matrix. In any matrix. That is what diagonal elements. Diagonal element, let us look at say. For suppose example, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what is 1 here? What is the position of 1? A 1 1.
A 1
What
1.
is 5 position here? A
A
2
2
2.
2.
What is 9 here? A 3 3.
3
Correct?
3.
So now here A 1 1 is equal to 1. A 2 2 is equal to 5. A 3 3 is equal to 9. Correct? Now look at
Yes,
this here
sir.
now. What I and J both are 1 1 or not? Both are equal or not? Look at this here.
Yes,
Correct?
sir.
Here 1 is what? What is I here? I is equal to 1 and J is also equal to
J
1.
equals to 1.
That is
I
I
equals to 2.
2.
J
J
equals
is
to
also
2.
equal to 2. That is I is equal to 3. J is equal to 3. Correct? Any doubts?
Yes, sir.
So this type of matrices
Yes.
are diagonal matrices. I mean, so diagonal elements, not matrices. Diagonal elements in a matrix. So these are diagonal elements. Look at this. What are the diagonal elements? These are my diagonal elements. Clear? Okay.
Yes, sir.
Any doubts?
No, sir.
Very simple. Now let us talk about diagonal matrix. We have seen only diagonal elements. Well, let's talk about diagonal matrix. What is it? Diagonal matrix. Diagonal matrix. See, a square matrix. It should be a square matrix. A square matrix. A square matrix such that Aij is equal to 0 for all I is not equal to j. Okay. Diagonal matrix is nothing but beta square matrix such that Aij must be equal to 0 and I should not be equal to j here. For all I should not be equal to j. For all I should not be. What is the meaning of this? Let me tell you. Square matrix such that Aij must be equal to 0 and for all I is not equal to j is nothing but what? It's nothing but look at it. If I say 1, 1, 0, 0, 0, 2, 0, 0, 0, 3, which is nothing but there should be only elements in only diagonal position. Rest of the elements are 0. Understand my point? What is the meaning of this? Element should be only in the position of diagonal. There shouldn't be any other elements. See here, all the guys are 0 or not?
Yes, sir.
All the elements are 0 or not? Yes or no?
Yes, sir.
Yes.
So here that is the meaning of this statement. Aij must be equal to 0. Look at this Aij. For all I is not equal to j, which means wherever you have I is equal to j, those positions must not be equal to 0. That is what the meaning of that. Okay.
Yes, sir.
Everywhere it should be I is equal to 0. For all I is not equal to j, which is nothing but wherever you have I is equal to j, there should not be equal to 0. Okay. For all I is not equal to j. Except that everything can be 0. That is the meaning of that. Okay. Now look at this. Now scalar matrix. In that itself, you write here itself. You write scalar matrix. Scalar matrix. What do you mean by scalar matrix? Scalar matrix is nothing but very simple. Look at this, beta. Aij equal to 0 for all I is not equal to j. Okay. Which is nothing but here you can say Aij should be some scalar, should be some constant. It shouldn't be equal to 0 again. Understand my point? Let's say an example. Here, look at this. Here it can be 1, 2, sorry. One, 0, 0, and close it, close it. Close it, close it. Fine, fine. Just close it. Yeah. You write this as, look at this here. For I is equal to j, you write ij is equal to k for all I is equal to j. Okay, understood? Where k is what here? Where k is a constant. Where k is a constant. Getting my point?
Yes, sir.
Look at this here now. Yes. Look at it. Everyone must be equal to 0. Look at 0, 2, 0, 0, 0, 3. Understood? You can take any example here. You say 1, 1, 1, 1. Look at this. Well, let's take 2, 2, 2, 2. All. I is equal to j, right? I said I is equal to j. Look at this. I is equal to j. I showed. So it must be equal. Okay. So here, so except 0, it can be anything. I told beta, look at this here. it should be aij should be equal to 0. All this should be 0. For all I is not equal to j, for all I is not equal to j, it should be equal to 0. For all I is equal to for all I is not equal to j, for everything should be 0. Okay, and I is equal to j should be constant ij. Wherever you have I is equal to j, I is equal to j, I is equal to j, I 0 j, it should be some constant. It shouldn't be equal to 0. Understand my point? Okay,
Yes.
here it shouldn't be equal to 0 again. Aij shouldn't be equal to 0. Why? Because if it is 0, what happens? It becomes a 0 matrix. Understand my point?
Yes, sir.
Yes. Now look at this here now. Now let's talk about one more concept. Yes. Identity matrix. What is that identity matrix?
0 1 0 0 0
Identity
1 0 0 0.
matrix. Identity matrix is nothing but all the diagonal elements must be equal to 1. That's it.
1.
Aij is equal to 0 for all I is not equal to j. Okay, and aii is equal to some k. That k shouldn't be equal to 0. Okay, that is what I'm trying to say here. You say here k, here you say k is not equal to 0. That is what I meant to say. Here this k shouldn't be equal to 0. If it is k is equal to 0, that becomes 0 matrix, right? So here aii should be equal to some constant. That constant is equal to what here? Is equal to 1.
1.
That constant be equal to 1, or else you simply say that aii is equal to 1. Example, look at this here. 1 0 0 0 1
0
0
1
0 0 1. Now
0 1.
can we say identity matrix is a scalar matrix?
No, sir.
We can say. Why? Look at this. Identity matrix is a scalar matrix. A scalar matrix is nothing but what? In diagonal position, it should be any scalar except 0.
Okay.
Look at it, in diagonal position, it could be any number. I have 1. Yes, still it is a scalar or not? Still is a scalar matrix.
Yes, sir.
So note, take a note. Identity matrix can be a scalar matrix. Understood my point? Identity matrix is a
Yes.
understood or not? Here aij must be equal to
Yes,
0
sir.
for all I is not equal to 1. Okay, aii must be equal to 1 for k. Here k shouldn't be equal to 0. Means like this k, right? I said this k. You say this is k, and where k is equal to 1. Okay, k should be equal to 1. Understood? Understood my point? See, all these should be a square matrices only. For square matrices only, it is possible. It diagonal matrix must be a square matrix, scalar matrix, identity matrix. Everyone, it should be a scalar matrix. Then only you can define them. Okay, understood my point?
Yes, sir.
Yes. Next, 8 matrix, null matrix. Null matrix. Or you say zero matrix. Null matrix or zero matrix. Basically, null matrix or zero matrix is nothing but all aij is equal to 0 for any order. A matrix which is having all the elements of 0. Look at this here, for example, let's say 0 0 0 0 0 0 0 0. Okay, any order. Understand my point?
Yes, sir.
Yes. Now look at this here. Let's talk about one second. I said identity matrix, right? This identity matrix also can be called as unit matrix, correct? Identity matrix also can be called as unit matrix, correct? Understood my point?
Sir, why it will be unit matrix, sir?
Sorry?
Sir, I'm asking that identity matrix, why it will be also known as unit matrix?
Why? Because unit is nothing but one, right?
Yes, sir.
Yeah. If all the elements of a principal diagonal in a diagonal matrix are one, then it is called as a unit matrix. Or you say, look at this here, a unit matrix of order n is denoted by like this. There is a, you can denote like this. In is equal in. This is how we denote. This is identity matrix of nth order. Okay. So
Yes, sir.
this is what the identity matrix or unit matrix you can say. Okay. Yes.
Yes, sir.
So you write a note here. Note. Let me write a note here. All identity matrices. All identity matrices are scalar matrices. Scalar matrices. Okay. Now all scalar matrices are diagonal matrices. Can I say? Isn't it? All diagonal matrices are square matrices. Correct? Any doubts? Any doubts?
No, sir.
No, sir.
Okay. Here, what I'm trying to say is all identity matrices are scalar matrices. Just now I told you, look at this here. Identity matrix can be a scalar matrix, right? Okay. Scalar is nothing but what? Here it can be any number. Look at it, in place of 2, you can have 1 also. Okay. Especially if you are writing 1, that is the identity matrix. Apart from 1, you write any other number, that is a scalar matrix. If you write 1 also, it is scalar matrix only, but you can call that as a scalar matrix as well as identity matrix. Understood my point? Understood or not, beta?
Yes, sir.
Any doubts here till this?
No, sir.
So identity matrix, all identity matrices are scalar matrices. All scalar matrices are diagonal. So identity matrices are scalar matrices are diagonal matrices are square matrices. Clear? Understood my point? Can we say that?
Yes, sir.
Next, equal matrices. Equal matrices. Equal matrices is nothing but there should be equal number of elements. There should be equal number of elements in both the matrices. Okay. You say, or else look at this here, you can write one more, or you can say simply two matrices A and B are said to be equal if they are of the same order and and their corresponding elements are equal. Understood my point? Matrices A and B are said to be equal if they are of the same order and their corresponding elements are equal. If their corresponding elements are equal. Clear? Understood my point? Understood or not?
Yes, sir.
So, I mean, that example, it should be same order and same number of elements in both. For example, look at this here. Here, 1, 2, 3, 4, 5, 6. What is the order of this matrix? What is the order of this matrix? 2 rows, 3 columns. Let's say A. Okay, and let's say B matrix. So 7, 8, 9. Not 7, 8, 9. You say something different. Let's give some unknown things. Let's say A1, B1, C1, A2, B2, C2. Okay, A2, B2, C2. Here, these are equal matrices. These are equal matrices or not? 2 rows, 3 columns. Here, equal matrices. Here, so equal matrices. You say these are equal matrices. Then A1 is equal to what? 1. A2 is equal to what? 4. Okay. And corresponding elements. Look at this. This position, this position, this position, this position, this. Can you all hear me? Dhairya, are you
Yes,
listening?
sir.
Yes.
Dhairya, are you listening to the class?
Yes, sir.
B1 is equal to 2. B2 is equal to what? 5. Again, C1 is equal to 3. C2 is equal to 6. So this is how I can write this. Let me write A1 is equal to 1. A2 is equal to 4. Clear? Next, let's talk about triangular matrix. What is it? Triangular matrix. In triangular matrix, very simple beta, you have two types of matrices, which are upper triangular and lower triangular matrices. Okay, upper triangular and lower triangular matrices. See, triangular matrix is nothing but a square matrix. A square matrix is said to be triangular matrix if the elements above or below the principal diagonal are 0. Okay, let's say that this is a matrix of above. You have the, look at it, here, here, and here. Let's say that we have something called any number 300 040 006. Okay, so principal diagonal elements are what now? These are my principal diagonal elements. So above 0, below also 0, correct? Above also 0, below also 0. So such type of matrix is the triangular matrix. Understood my point?
Yes, sir.
So we have two types of matrices. Under this, we have two types of matrices. What is it? First, upper triangular matrix and lower triangular matrix. Lower triangular triangular matrix. Upper triangular, lower triangular. Upper triangular matrix is nothing but what? Upper triangular is nothing but the downside element should be 0. Look at this here. Here, Aij is equal to 0 when I is greater than 0. Okay. Here, Aij must be equal to 0 when I is less than 0. Understood my point? Example. Here you take 1, 2, 3, 0, 4, 5, 0, 0, 6. Okay. Understood my point? So these elements, look at this. These guys must be 0. Upper triangle is nothing but below element should be 0. Understood my point? And now lower triangular matrix is nothing but
Upper element
upper
should be
element will be 0 like that. 1, it says 0, 0, 2, 3, 0, 4, 5, 6. Now look at this here. These guys are 0 here. But in triangle shape, this element must be 0. Clear? All right, clear? Understood? All look at this here. Why?
Yes.
Here A11, A22, sorry, A12, A13, A21. A21 is also equal to 0. Look at it. All I less than j elements are what? I less than j positions are 0. A21 is equal to 0. A31 is equal to 0. A32 is also 0. Now look at it. I is what? Sorry, I is greater than j here. Here also I is greater than j. Here also I is greater than j. Now look at this here. A12 is 0. A13 is 0. A23 is also 0. Now look at this here. Here I less than j. I less than j. Here also I less than j. Okay, isn't it clear? Understood my point? Is it clear, beta? Is it clear? 1 second, just a minute.
Yes, sir.
Okay, children, understood what is upper triangular matrix and lower triangular matrix? Clear? Is it clear? Understood my point?
Yes, sir.
Yes. Next, singular matrix and non-singular matrix. Singular matrix and non-singular matrix. First, suppose singular matrix is nothing but if determinant of a matrix is equal to 0, that is singular matrix. Non-singular, what is determinant, sir? That is our next lesson. That is our next lesson. I'll teach you that determinant. What is that determinant? Okay. In the next lesson, I'll teach you that. If determinant of a is not equal to 0, that is
Non-singular matrix.
very simple. Is it clear till this?
Yes, sir.
Okay. Yes. Yes. Guys, now look at this here. Equality of matrices and equivalent of matrices. We were learning equality of matrices. Where is that? Yes. Equal matrices, right? Equality of matrices. What is the difference between equality of matrices and equivalent of matrices? Equality of matrices is nothing but here A is equal to B matrix. Here A is similar to B matrix. Understand my point? Difference. A is
Yes,
equal
sir.
to means equality. Equivalent is nothing but A is similar to B. Understand my point? Sir, what exactly is the difference between these two? Okay, let me give a table here. Okay, here what happens is beta, look at this here. Okay, here what happens is, for suppose I have, let's say that this is a matrix. In this, you say A matrix you have, which is Aij of order m by n you have, and let's say that you have another matrix called B matrix, which is elements of Bij you have, which is order of R by S. Correct? Now look at this here. Here m must be equal to R. The first condition in equivalent matrix is what? I'm writing here the difference. Let us write something somewhat here. Okay. Here, beta, look at this here. In equivalent matrix is what? The first condition is what? Here m must be equal to R and R must be n must be equal to S. Okay. And what is the next condition here? Here Aij must be equal to Bij. A must be equal to Bij, which is nothing but corresponding elements, isn't it? Corresponding elements. But here in equivalent matrix, m must be equal to R and n must be equal to S. That's it. You need not to bother about corresponding elements. Need not to be, here corresponding elements need not to be equal. Where? In equivalent matrices. Understood my point? Understood beta? Here equivalent matrix is nothing but their m is equal to R. Their order must be equal. Here look at this m. This is number of rows is 2 means here also number of rows must be 2 only. Understood my point? Number of columns is 3 means number of columns also same only. Understood my point? Hello? Here number of rows are m beta, number of n, number of columns are n. Here number of rows are R, number of columns are S. So here number of rows in this matrix supposed to be equal to number of rows of another matrix. Number of columns of this matrix supposed to be equal to number of columns of second matrix. So that is what I meant to say here. So that is what I wrote here. Next, their corresponding elements must be equal here. What is it? Corresponding must be equal. This is a difference beta. I'm writing the difference between these two matrices. This is the corresponding. Look at it. These are the difference between these two matrices. Okay, understood my point?
Yes, sir.
Okay, here number of rows same. First condition is same for every matrix. For first condition is same for these two matrices, but here corresponding elements will be equal. Here corresponding elements need not to be equal in equivalent matrix. Okay, beta. So I'll be stopping here. So in the next class, what I do is I'll continue with this thing. Okay, in the next class. Until then, goodbye. Please do revise the notes and come to the class. Please don't miss the next class. Again, you will be under trouble if you miss it. Okay? Is it clear, Dhairya, Adesha, Pravalika?
Yes, sir.
Yes, sir.
You may leave now. Thank you. We will meet in the next session. Goodbye.